Hi YouTube, I think it's time that I show you my solar observatory. In fact, it's in my condo. It's in my bedroom. There you go. It's right in front of the window. So let's go into the details. And by the way, I'm on the 12th floor of a high-rise building, I guess. And I'm in this large city. And so I had to find a way to be able to observe the sun, my favorite astronomical object, from where I lived. And so I did some observing from the balconies on each side of the property. And I said, what is the best way to maximize my observing time? And the way I found is a bit unusual, it might be even unique, is to set up this telescope on the drive base, on the mount here, polar aligned in my bedroom. And the way I would observe is to look through an open patio door. So that's what I found, and it's very easy to use. It takes me about less than a minute to align on the sun and start the mount here to track the sun, and I can take pictures and observe visually. And the goal here was to try to look at the sun and take images in many wavelengths, more than one wavelength, more than the white light images that you see usually. So it all started with the hydrogen alpha filter. This is the main telescope. I've had this one for a while. It's a Teleview 102i. The reason why I chose this telescope is that it could take the largest Coronado hydrogen alpha filter in the front. It's 90 millimeters in diameter, and it screws straight into the front cell of the telescope, or the dew shield, sorry. It has two sections, this filter. It has the étalon at the front, so 656 nanometers wavelength, 0.7 angstrom bandwidth, very, very narrow. And the second filter is here. And what this filter does is choose more specifically the wavelength that is being filtered by the front filter, as well as removing any infrared or dangerous rays coming from the sun. So I can look visually in this one and see hydrogen alpha. And hydrogen alpha will show you a surface of the sun, specifically in the lines of hydrogen. And at that frequency, you see all the protuberances and the storms on the surface of the sun, much more than any other wavelength. They're more spectacular. You can see protuberances sticking out from the side of the sun when the conditions are right. And I can do imaging with no problem. So I'll show you a picture that I've taken with this telescope. When I wanted to expand a little bit more than hydrogen alpha, which I've been doing with Lise, my girlfriend, for I guess 15 years now, we wanted to expand into other wavelengths. And after seeing a presentation by Raymond Lalonde at our astronomy club, I fell in love with the calcium K line, which is frequency or wavelength of the sunlight that I can't see really with my eyes, but I can image it using a camera, monochrome camera that you can buy on the market. And so I looked for calcium K filter. I think it's 396 nanometers, so it's really deep blue. I can't see it with my eyes, but the camera sees it very well. So I was looking for a combination of camera, filters, telescope that would show the whole sun in one image in the field of view of that telescope. So I found Skywatcher. It's a 102 millimeter diameter, about 4 inches. F5, the focal ratio F5, so about 500 millimeter focal length. And I found a Lunt B600 calcium K filter, which is situated here. It's the whole part of the filter, so your sun is exposed. You see directly the sun through this aperture. It's not filtered at all like the one for hydrogen alpha. And here I coupled it with a camera that I found which had the right size so that I can see the sun fully with this telescope. And so this is a ZWO ASI 174 monochrome. Great little camera. It has about 2 megapixels. They're relatively big, 5.6 micron on each side. Very sensitive. I do exposures in less than a millisecond for calcium K and about 1 millisecond for hydrogen alpha. I can switch that camera on the two telescopes. On this one, the sun doesn't fit in the field of view, so I have to put a focal reducer. But otherwise, I switch the camera from one telescope to the other. This ruler here helps me align mechanically the camera with the telescopes. And then after calcium case, I'll show you an image or two that I took with this. All right, now the third telescope that I use is for what we call white light. And it's a way to look at the sun that is very similar to if you just put regular solar filters that they sell on the market. In the market, for instance, the glasses, you'll see the sun in yellow or white, and you see the sunspots. That's what's great with what we call white light. Now, the professionals will use filters that are much narrower, obviously. And any filter here, because it's narrower, a narrow bandwidth, will help me with the turbulence that I can have on being on the 12th floor of a concrete building. So what I did, the combination I found here for this type of filtering is the same telescope as on the other side, Skywatcher, 102 millimeter diameter, f5. What I did here is a combination of two filters. I found a filter that was from Edmund, and it's a laser cleaner filter, laser line filter, I think. And it has 1 nanometers bandwidth, and it is 514 nanometers, so in the yellow color. So I combined this because this was too bright for my eyes and the camera. I combined this with the Bad Air white light filter, neutral density 3.8. This combination gives me the least turbulence in my image for white light in the yellow band. So that works pretty well. It's not as good as the other two because the bandwidth, this is 0.22 nanometers, this is 0.07 nanometers, and this is 1 nanometer. So it's still pretty good for imaging. Not the best, But this is relatively good, and so is this one. All of this is mounted in my bedroom using a Sphinx mount from Vixen. And that mount works very well. I oriented the whole thing towards the North Star, and so when I start it up, it's already aligned, so I don't have to do a star alignment or anything. I'm on the sun, so the images are very quick, so I don't need to do anything particular for tracking. It's not like a long exposure, it's always in the millisecond time range. So that works very well, and it again, it's very fast to set up, and my limitation is the field of view that I have through the door here. I have just a few degrees of the sky. It's always just before sunset, and those are the limitations of the system, but at the same time I'm very quick at using it when I come back from work. Before supper I can set it up and put it to work really quickly. And when I do imaging, I have a laptop on this side that I can use to power the camera as well as take pictures with it. So there you go, you have it, my solar setup in my bedroom. Might do another video on imaging, what I do for imaging, which is very simple. But there you go. You can do solar imaging in particular circumstances in your bedroom. Hope you liked it. Thank you.